Hello everyone. Today we are working on an HSM simulator. Basically, HSM is called hardware security module. That is like the we can use say as the security backbone of today's modern internet when we are discussing about the online banking, online social media, and other things. They all need keys to manage their encryption, right? And HSM is basically a system that is used to store and manage the keys securely, right? But HSM is an hardware module basically. So when you are using OpenSSL and other things to manage the keys, you need to buy a hardware module, hardware device to manage HSM, right? But to overcome this issue, because lots of smaller companies not able to buy this hardware module because these are expensive, right? So they gave us a the OpenSSL design a software module for that is called SoftHSM. Basically, that is we are discussing today in our project video. So this SoftHSM work like a hardware module, same as using PKCS, Public Key Standard 11, to encrypt, manage, and distribute the keys between the cryptographic devices and the HSM. So how we proceed? So to proceed, first we need to download the SoftHSM version 2.3, right? So that's available in a GitHub repository. So I'm just going to download download it from the GitHub repository. So basically we can use GitHub repository or also an OpenSec repository. So this is available on both them. So here I'm using the OpenSec repository to download the tar file, the zip file for the SoftHSM 2.0, right? So after downloading the tar file, right, so we need to uncompress that file, right? So to uncompress that file, so we need to uncompress that file. So I'm going to uncompress it. Just give me a moment. And now you can press enter. Now your tar file is uncompressed, and now you can press ls and see all the available directories in your system, right?
Now we need to change the directory or can direct you to this SoftHSM directory.
Now we are going into a SoftHSM. So we are now proceeding to a SoftHSM. So cd to the SoftHSM and press enter ls. So this is basically the SoftHSM directory where the tool is available, right? Okay, so now we are in the HSM drive. So first, before using the software, we need to configure the software basically, right? So to configure the software, we are using the inbuilt.
But before that, we need to install those files, those libraries which are required to install this software, which are like automake, autoconfig, libtool, and pkg-config.
I'm not able to show you that things because those are the repositories are already in my system. I'm already installed that compatibility, so I'm not able to install it again. So I'm just skipping that step and just going to directly configure the software, right? So now I'm going to configure the software. So it's just configuring and checking all the compatibilities and the availability of libraries. If anything is missing, it's give us an error. If there's nothing is missing, it's gonna install it, and then we need to make the software again.
As we already installed those libraries, that's why we are not getting any error. But if you haven't installed those libraries before running config file or config command, then you will see an error like OpenSSL head is missing or something like that. Please make sure these libraries are installed before running config command.
So now, so now if you have any issue with the config and other things, right? You can use the config help part to know about anything. If you need to find out any issue, you have any issue with that, you can use this thing, and this thing will give you all the information what you need to configure and other things, right? But we already configured the software, so now we need to compile it. And for the compile, we are using the make command. So now we are compiling the software.
But sometimes it don't run properly because we are not as a super root user. That's why we need to write sudo make, and we need to write password.
Okay, so after that, like we know everything is like the make is the compilation is done. Now we need to finish the installation, right? So now we to install everything, we need to use the install again the make command with the install command. So we are using. So now we are installing the SoftHSM in our system, right? So
After this, we need to export the key for this. Soft.
So basically this is the location of the configuration file where we can store all the configuration of the SoftHSM, right? And all the information, tokens and other things, right?
So here goes our path for the config file. So we need to verify where the config file is. In some of the systems, it's by default is in the user, in user file in home directory. Over here I can show you. Sorry, in etc by mistake. We can type and search for it. You can write other name as well, SoftHSM. So here's the name. So we know that it is in the etc folder, so we can explain it properly. So here goes the address for that, /etc/soft/hsm to config. So when you press enter, it shows nothing. As we have already exported this thing earlier, so this might be a reason that it is not exporting now, because it's already in this system. So now then we need to make directory for that, token directory.
Token directory is basically part in the system where like HSM manage the tokens, basically store the keys securely to protecting from outside users and other things. That's the basically the part of the token directory. So we are making the token directory.
So cd in the fork directory, and then we need to invite the token using these commands. So we are using slot 0 for this, and labels as like my token 1. So while after executing this, it will create my token 1 as a, and it will ask for the password for SU, which means
SU is basically password that is used by the administrator to reinitialize the token if he need in the future, right? So that's called SU password.
So I'm setting it as in 987654321 and re-enter.
Now it's asking for the user password. The user password is basically given to the applications to interact with the token. So by using the user passwords, the the user pin, the applications interact with the token that is generated by the HSM.
So I'm writing a Bikram as a password. Oh, my mistake. So as the slot 0 is already initialized, so it doesn't exist at that time. We can even write the slot 1 as well. Pin same. So it shows token has been initialized and is reassigned to slot 81519460H. So this is a slot number which we have for this token. So after this, I think this is the last thing, and we can verify. Just a second. Now we need to verify that what we have created is like runnable or not, and this token is actually validating or not. But before that, we need to install one more software. Install OpenSC. So it requires super user access. So sudo. It is already installed, so it won't do anything. And then we need to write PKC. Sorry, I can't. So this is the public key cryptographic standard for encryption.
So basically we are using PKCS standard 11 to access the token that we are generated in HSM to see that is how it's work, right? So we are basically already created token, the security and everything. Now we are testing it's working or not, right?
So -T the switch. So we are checking this against the switch. We need to write the password for the pin, which is Bikramjit.
Like already told you, we need a user password to access the token, right? So now we are needing user password to access the token.
So here it shows like slot 0 with present token is this on its address. This is token 1. So it shows that seed random and seed generate random seems to be okay. And the main thing that MD5 hash is done and SH is okay, which means that what we have created is verified with the switch that this the keys are being shared and like doesn't require any additional
like keys are shared securely without revealing the keys to the third party. And here I want to discuss one thing more, the seed random. So I also want to explain you what seed random, right? So seed random is basically to do the cryptography. All the cryptography is basically based on the random numbers, right? To generate a random numbers, we need a seed, like we for a plant, to grow a plant, we need a seed. Same thing in a cryptography, to generate a random numbers, we need a seed. So here we like implanting the seed, and that's called seed random number. That with the help of that, we can generate other random numbers to perform the key generation and the encryption and cryptography and other things.
We haven't implemented signature in this and other decryption we haven't done for this. But so as this is a bigger project for us and we haven't got much time, we are doing as much as we can. This implementation requires a lot of time, and we are just doing a demonstration how to do these things.
Plus this thing is not 100% accurate, and other things is not recommended for the production environment and still have limitations. If we want to check the exact evaluation and the performance and the working of HSM, we need a hardware module still to perform that. So only with the software HSML, we will just check the testing and other things in it, like without putting it in a production environment, right? So that's all we do to perform the work in HSM. If you have any questions, just post on the link below our video, and that's all. Thank you very much.